Despite their tremendous success, large language models remain slow, expensive to operate, and challenging to retrain or fine-tune in standard environments. Moreover, they lack several critical factors essential for decision-making, including interpretability, bias control, reasoning, and common sense. On the other hand, we can leverage decades of domain-specific machine learning advancements by training small models for specific tasks. These models are more precise, as their reasoning is tailored to a single purpose. They are cost-effective, fast, and can be combined into ensembles for multitask applications. Tool calling can greatly enhance performance by integrating specialized external models and APIs for specific tasks. Instead of relying solely on a single large model, tool calling allows precise, efficient, and cost-effective solutions by delegating tasks to domain-specific systems. This approach improves accuracy, speed, and adaptability, while enabling seamless multitasking through dynamic tool integration. By adopting an agentic approach to tool selection in large language model tool calling, we can enable dynamic and intelligent decision-making when choosing the most suitable external models or APIs for a given task. Rather than relying on a predefined set of tools, an LLM-driven agent can assess the context, select the optimal tool, and adapt in real time. On the other hand, GeoAI integrates geospatial data with artificial intelligence, and given the vast range of potential applications, it makes perfect sense to combine small models with LLMs using an agentic tool calling approach. Therefore, we are excited to present this methodology to you. Let us showcase our agentic tool calling system. We begin by selecting a specific area of interest on the map. This anchors all tools and data to that location. With tool call details enabled, you get a better understanding of what happens behind the scenes. Let's query the weather. The agent selects the appropriate weather tool with the necessary parameters. Once processed, we receive our answer. On screen, you'll see both our system's response and a large language model's output without our context. As expected, the model cannot answer and suggests external sources instead. Meanwhile, our system invokes the tool to retrieve weather forecast data, leading to a precise and informed answer. Let's clear the chat history and select another area for our next question. We select an area which consists mostly of a forest near our previous area and ask our system to determine whether it is suitable to grow potatoes here. The agent starts by a brief summary about potatoes and an explanation of next steps. It then chooses to combine multiple tools to solve our question, retrieving land use, land cover, elevation data, and upcoming seasonal temperatures. Without this context, the language model is still able to offer general potato growing advice, such as soil preferences and ideal climate conditions. However, it lacks the ability to evaluate the suitability of our specific location. In contrast, our system goes a step further by analyzing up-to-date land and temperature conditions obtained by the tool invocation, ensuring that the response is not just informative, but also directly relevant to the selected area. This allows us to make well-informed decisions based on precise environmental factors. We clear the chat history again and move to the last example we have prepared for you. Selecting an area with water body presence, we compare the ability of our system and a large language model without context to detect this. Our agent selects the land cover tool to get a description of all zone types that are present in the area. Our system answers the question based on this data, drawing conclusions about the connections of the water courses with other zones. Similar to our previous examples, the large language model gives us only general information, but this time also providing partially incorrect and irrelevant statements. It mentions a different river than the one present and says Pilsen City is in the vicinity of our area of interest, even though Prague would be a much better choice, as both Prague and our area are in the central Bohemian region. As demonstrated throughout these cases, our approach bridges the gap between generic AI-generated insights and truly data-informed decision-making. By dynamically integrating real-time data sources, our system ensures that responses are grounded in accurate, context-aware information rather than relying on broad assumptions. This enables more precise analysis, enhances reliability, and allows for informed actions tailored to specific conditions. Whether assessing environmental factors, evaluating geographic suitability, or retrieving live data, our agentic system continuously adapts to deliver meaningful, situationally relevant insights.